Hey, this is Math 2, Unit 10, Worksheet number 8, talking today about the average rate of change. We're going to go over some of today's homework problems, okay? So we're going to find, first of all, the average rate of change from 2 to 5 for this function right there. So what I want to do, first of all, is I'm going to plug 2 in the place of x. We have 2 squared, which becomes 4. Then I'm going to plug 5 in the place of x. We have 5 squared, which is 25, okay? And so my rate of change is going to be my y2 minus my y1 over my x2 minus my x1. What were those things again? Well, these are my x values here that I'm plugging in to find my y values over here. So my second y value is actually 25 minus my first y value, which was 4, divided by my second x value, which was 5, minus my first y value, which was 2. Okay, so that's kind of the equation I'm looking at for that rate of change. And rate of change is really a nice fancy way of talking about our slope when we're talking about a graph for how much it's changing going up or down, right? So 25 minus 4 is 21, 5 minus 2 is 3, and we can reduce that down to 7. So the rate of change of this graph is going to be 7 in that area. So from going from point 2, when x is equal to 2, x is equal to 5, the rate of change is going to be 7. So again, if you graph that out, for example, right, and you go 1, 2, 3, 4, 5, 6, 7, and we know we're going to go up from 4 to 25, so we can count by 5s here, 5, 10, 15, 20, and 25. When x equaled 2, we're at about 4. When x equaled 5, so 3, 4, 5, we're going to be up here at 25. Okay, so because this is quadratic, we know it's going to be curving like so, but the rate of change, meaning what's happening from this distance here is that slope is going up at about 7 to 1 kind of as a ratio there, right? Going up 7 for every one it's going over. Now, it's not exact because it's a rate of change and it's quadratic, so it's not a linear function. So, but that's what our slope is going to be. Over here we have 2 times x squared. Okay, so looking at my x value and my y value, and I want to go from 2 to 5, let's do 2 times, there's my x, 2 squared, which is going to equal what? 2 squared is 4, 4 times 2 is 8, and over here it's 2 still times 5 squared. 5 squared is 25, 25 times 2 is 50. So again, my y2 minus my y1 over my x2 minus my x1. What's my y2? My y2 is 50 minus my y1, which is 8, divided by my x2, which is 5, minus my x1, which is 2. So 50 minus 8 is 42, 5 minus 2 is 3, and that can be reduced down to 14. So the average rate of change of f of x is different than g of x, right? F of x is going to be average rate of change is 7, and this one is 14. What does this mean in relationship to the graph? Okay, what it tells us here is that g of x has a greater slope, right? It's 14. That means it's going in a sense up 14 over 1. That's a greater slope. Okay, so it's going to be going up, maybe we can say steeper, if you want to call it that way. So it's going up faster, steeper. Alrighty, so again, if we were to graph this over here, back on this first one, right at 2, we're actually at 8, which is going to be here, the second one, and at 5, we're at, what do we say, 50, so we're way up here somewhere, right? So it's going to be going like this, so it's going up faster. So this is 2x squared, and this is what x squared looks like. So it's going up a lot steeper, a lot greater slope. The next one, 4, 5, and 6, we have 3x, find the average rate of change from 1 to 4. So we're going to use those values and plug them into that x right there. So here's x, here's y. So we're going to do 3 to the first power. 3 to the first power is going to be equal to 3. And then we'll do 3 to the fourth power here. So that's 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. Again, we're going to do our y2 minus our y1 divided by our x2 minus our x1. 81 minus 3 is equal to 78. 41 minus 1 is equal to 3. That does reduce down to 16, believe it or not. All right, then we have, given k of x is 2 to the x power, find the rate of change from 1 to 4. So same idea, here's my x, here's my y. So we're going to do 2 to the first power, which equals 2. And then we'll do 2 to the fourth power, which equals, well, again, 2 times 2 times 2 times 2 equals 16. So we'll do 16 minus 2, again, y2 minus y1, over x2, which is 4, minus 1. 16 minus 2 is 14, divided by 3, and you have a number like that. I could leave it like that, but because it talks in the next question about the average rate of change is different, what does it mean? I'm going to turn that into a number I can work with a little bit better. 3 goes into 14 4 times with 2 left over, so 4 2/3. So which one of these then has the greater slope, right? Looking here, we would say that h of x has a greater or steeper slope. So if you were to graph that out, that's what that would mean. Okay, it says find the rate of change for f of x from 1 to 4. So from the very beginning, f of x we said was x squared, and now we did last time we did 2 to 5. From 1 to 4, what do we get? Here's x, here's y, using that one there. So when x is 1, you end up with 1. When x is 4, you end up with 4 squared, which is 16. As a rate of change for that first f of x, you do 16 minus 1 over 4 minus 1, which is 15 over 3, which is 5. So f of x has a slope or a rate of change of 5 compared to k of x, which had a rate of change, k of x, which is right here, of 4 2/3, right? From back up in number 5. So what can we tell the difference there between those ones? We would say that which function has a greater rate of change? We could say f of x has the greater rate of change, but not by much, but just by a little bit more. 5 is bigger than 4 2/3. All right, and that really is the basics of today's lesson. On the back side, you have some review, which is good to practice a little bit of review stuff here. And so what's in here, I'm not going to go ahead and do this here because this again is review from your previous lessons, so you should be able to work that out. The idea is for you to practice this. You will have these same types of problems on your upcoming tests, so I'm not going to give those solutions right now. I really want you to practice up there. And down below, we have some given functions, match them to the correct graph. And so you could probably do some of this without even doing a lot of the work. Okay, why do we say that? Well, because of the form that they're in. Looking here, we can guess what is going to be our y-intercept. Y-intercept here is going to be at -1. So which one is that going to match? Well, that seems to look like it goes with that one right there at -1. Over here, what's our y-intercept at? We could say it's at +8. Now those are both up there, so they're both positive, it seems to look like. But this one is at 5 and that one's at 8. So if you were to count it up, that looks like 8 and this one looks like 5. So without doing much work, just looking at the y-intercept, because in standard form, we can tell that. We can also tell because this is positive, that's going to be curving up and down, so that tells you right away it's B. This is negative, so it's curving this way, and negative. And because this one is a 3, it's going to be narrow, right? It's going to be like skinnier, or thinner, however you want to say that there. So that is a skinnier one than that one, which is going to be wider. So you don't have to do any work, you can just look at that and figure that out. But again, that's a review from what we did back in some of our earlier lessons. Okay, that's it for today. See you next time.